K alpha. One of the questions I get a lot from customers is relating to detectors, the different types, what does it mean, and how does it relate to my application needs. So that's what I'm here to talk about today, is the detector technology. A lot's changed over the years. In years past, what was mainly used was what we called a gas-filled proportional counter, or prop counter. It is gas-filled. Here's the detector area here. I've got an example. And basically what happens is the signal's converted here. You've got a preamp. You've got all this connected through wires to an MCA board. And basically some of the one real main advantage of this is it's got a big window. It can collect and handle a lot of photon counts, but it really has a lot of negatives. All of that different, the wiring and the signal conversion, it adds up to a lot of noise. You get a high baseline noise. You also get very poor resolution. So neighboring elements like nickel and copper, they really overlap bad. So sometimes you have to use secondary cobalt filters to separate some elements. Also, they aren't very stable over time. Since it's a gas-filled detector, fluctuations in temperature, humidity, you might have a slow leak over time. It's just going to lead to inconsistencies in your data. You're going to have to recalibrate a lot. The newer technology is more of a solid state detection system. I've got an example here of one of our silica pin diode detectors. You've got two different types of solid state detectors that are used now. The pin diode, or just the pin detector, or a silicon drift detector, or SDD. So basically a pin detector, it adds, you can see the size is much smaller than this whole assembly here. But basically what it does is it improves your resolution greatly. All right, so you can resolve those neighboring elements like nickel, copper, zinc, things like that. Also, it has a very, very low base noise level, so it really improves your sensitivity. So for new applications like INAPIG, where you're measuring gold, palladium at 2-3 microinches or 0.1 microns or less, you really, really need that low base level. You need that high signal to noise ratio, which the solid state detectors achieve. And also they're a lot more stable over time. Again, since it's solid state, you're not going to have those fluctuations with temperature and humidity. So you're not going to have to recalibrate near as often. So this is the pin detector. We also have a silicon drift SDD detector. And basically that's a pin detector with just a little bit more capabilities. You get a little bit better resolution, get a higher count rate throughput capability. It's really only used in specialized applications. I mean, the pin detector does such a great job, but the SDD does add some things on top of the pin detector if you're using a bigger spot size or if you really, really, really need that extra resolution. But basically with the Bowman system, we don't even use prop counters. We just use the solid state technology. Again, it adds up to a really, really stable system, and it just gives you so much more versatility for coating thickness, for bulk composition analysis, alloy analysis, solutions, again, getting on a very, very low concentration level. So, I hope this kind of helps you understand what the difference in the detector technology is.